So this is a continuation of our last video where we did a one-tailed hypothesis test when we didn't know the standard deviation of the population. However, let's say we hypothetically found a report in some old lab that somehow knew the population standard deviation was 15 milliseconds. So remember, we have the population average of 250 milliseconds, which is just given as our average of the population. Now we know the population standard deviation is 15, which is larger than our estimate for the population standard deviation in our last calculations, which was about 6.5. But these are what we're working with now. Now, if we're working with the z-score instead of the t, steps 1 through 3 are all the same of establishing our hypothesis test. Our hypotheses are the same. And then calculating the mean from our sample. Step 2 was calculating or gathering our data, and step 3 was finding our sample mean to be 212.5 milliseconds. Okay. So now, continuing on, we can reach step 4 in this version, which, if you recall, is finding the test statistic. Okay. Now, I already explained what that was in the last video. In that case, we have our new formula for this being x bar minus mu over. You'll notice how this is what in math is called isomorphic. It is the same structure. In fact, it has all the same variables except for what we're finding, and we're just replacing the last time estimate for population standard deviation with the real population standard deviation. And so we have the sample mean, we have the population mean, we have the population standard deviation, and we know we still sampled 4 people. So this is a fairly straightforward calculation. It's just a plug and chug. Where we have our sample mean minus our population mean all over. We're given 15 milliseconds for our population standard deviation. We still are sampling 4 people. If you plug that into your calculator, it comes out to negative 5.0. Okay, this is a measure of how extreme our value is given all these factors of our sampling and the population factors. Okay, so now we can move on to step 5, which we can do 2 ways to determine the rejection region. We can use the table and we can use our calculators. I'm going to show you both because on an exam or a quiz I will be giving you the table, but you can also use your calculator if you let me know. So with the table, I say this isn't as two-dimensional as our z distribution, where we have 2 factors, the degrees of freedom and our certainty. Genuinely, we just needed these degrees of freedom to help us compensate for not knowing the population standard deviation. But because we're given that, now we just have 1 factor. Okay, there's 2 tables here, and that's finding the probability of this distribution from the left or the right. Or sorry, rather, it's before 0 and then after 0. You can find tables for from the right, but I find that, like using the symmetry in our last video, you can usually get around with just finding the negative of whatever you're looking at. But we're looking at a left test, and so we want to find the region bounded by 0.05. Okay, we want the 5% to be low in the lower region, like we did with the t-table. And so notice that we have our 2 values, but this is just the first two digits and then the third digit of what we're looking for. We want to be have 0.05 or 5% of the region shaded. So literally one roundabout way is just to find the 0.05 here somewhere. Looks like it's about here. So you can see that is negative 1.6, 0.04. So that's negative 1.64. So the table says z is negative 1.64. Notice it wasn't exactly 0.05, so this is a little bit off, but luckily we can also use our calculator, which if you have a TI-83 or 84, this should be fine. If you're using different calculators, figure out how to use it on there. But like I said, I still provide a table if that isn't an option. So we've used this for second, vars to hit the distribution, section, invert normal, and we type in from the left shaded region onward, how much do we want shaded? 0.05. That gives us a more exact value. Okay. If we wanted if we were doing a right-tailed t-test to find if something was improving and we wanted to find the right region, we can type in 0.05, and that's the left region. And then if we find the negative, then we're finding the upper region. I'll explain that in just a second. So using the calculator, we have a better updated value of negative 1.645. We can cut this off. The more digits, the more accurate, but this will be fine for our class purposes. The t-table is good, but because we can use it on the calculator, we're going to use a slightly more accurate value. I'm not going to ding you on those on your homework or the quiz, though. But like I said, this is the value for marking off let's see, negative 1.645. That's z critical, the region that is cutting off the lower 5% of the values. Okay, and if we were doing an upper test to find, let's say if z was greater than 250 milliseconds, in some improvement other experiment we're doing, then we know that because of symmetry, the upper 5% is positive 1.645. And so knowing how to switch between these and knowing the symmetry and that this is centered on 0, this is why we use standardized curves, is because they're so much more useful. Okay, so I'm going to erase this. So we know our critical region to be sure enough that we have enough evidence to reject our null hypothesis is anything less than negative 1.645. Okay, but our z-score was negative 5 over here. So this also puts us well within the rejection region, the region to reject our null hypothesis in favor of our alternative hypothesis. So both cases, we can reject the null hypothesis in favor of the alternative hypothesis. We can say we have significant confidence in coming to this conclusion. And two things I'd like to, again, reemphasize. One, this is only a conclusion that it improves reaction time, improving being a reduction in reaction time. Okay, we just know that we have statistically significant evidence that our reaction time is improved. We're not making a statement of how much it's improved. And two, hypothetically, so getting used to the software. Hypothetically, if our z-score was outside of the rejection region, and we weren't able to reject the null hypothesis, we will say we fail, and the wording of this is very important, we failed to reject the null hypothesis in favor of the alternative hypothesis. But what I also really want to emphasize is that failing to reject the null hypothesis is not the same as saying we accept it. Or rather, it's not the same as saying we have confirmed it. We haven't proven it. Okay, we have just failed to reject it, and it being our default, but we have not proved that the serum doesn't work. Because remember, with a 95% confidence, we expect 95 out of 100 of them to give us this accurate result, but there's still possible to find the 5 that don't. Okay, so these are very important to conclude, and I always want to emphasize that these two are important. We aren't telling you the magnitude of how much we've improved, and failing to reject the null hypothesis does not mean we have proven the null hypothesis.